All right, so we're solving systems, and this is really truly review from some algebra 1, some algebra 2. Okay, this is algebra 1, yes? 8th grade, pre-algebra, I don't know. Graph these lines, find where they intersect. Can you handle that? I can't with my bifocals, but this one starts at 5 and goes up to and over 5. This graph paper is so tiny for me. Yep, see, that wasn't even up 2. Okay, I think it's that one. Okay, then this one down here, I'll do in blue. Starts down at -4, goes up 11 and over 5. Miraculously, where does that intersect? Yeah, what do you know? Not there, but I'll fix it. Anybody name that ordered pair where they intersected right there? Okay, so that's what the answer is, and you need to have an answer. And then we need to talk about how you could check that answer. It has to work in both equations, okay? So if I put the 7 and the 5 in, two-fifths of 5 would just be 2, so I'd have 2 plus 5 equals 7. That checks. All right, here I'd have 11 minus 4 equals 7. That checks. You don't have to show a check, but if it's for points on a quiz, is it worth typing it in on your calculator? You do get to use a calculator. You just don't get to use a graphing calculator for this quiz, okay? All right, what do we have to do a little bit harder on number 2? Yeah, we got to get it in y equals form. Maybe x minus 4 equals y. How does that look? Looks good to me. And y equals negative 9x plus 6. So if I do the top one in red, it starts down here, and it's going up 1 and over 1. Something like that. Right, then the other one starts at 6 and goes down 9 and over 1. Yeah, try to freehand. See how that goes? Not good. Looks like a cubic. What's wrong? So what's the point where they intersect, guys? 1, -3. Everybody okay? Yep. These are both what are called consistent systems because they have a solution. What would it look like if it didn't have a solution? How could you draw two lines and they didn't intersect? Right. If they were parallel, then it would be an inconsistent system. Would have no solution. Does that make sense? If you graphed the two lines and they were really the same line, then it's called a dependent system. Okay? And that has many solutions. We'll talk more about that in a minute. Ooh. Number 3. These are inequalities. Couple quick things. These two symbols mean that you draw a dashed or dotted line. These two symbols with the or equal to mean you draw a solid line. Does this sound familiar? Yep. You should be. Okay, these two symbols are both greater than or equal to. And if you have a y equals equation, these will mean that you shade above the line. I just totally... Anybody want to argue with me on that, please?
Well, less than would be below.
Yeah, these are less thans, not greater thans. Just to confuse you, and you would shade below the line. These are greater thans. And they would cause you to shade above the line.
I remember in like 3rd grade when my biggest fear was forgetting which one was less than and which one was greater than.
These little smushed over L's. Yeah, guys, this is not about the alligator eating the bigger one, okay? Because we have to know the symbol when we get to this level. This is a less than. It's like a little smushed over L, okay? This is not an L. It's backwards. All right, number 3. This is a less than, so we're going to shade below the line, and it's going to be a dotted line because it doesn't have the or equal to. Now, if I start up at 5, how can I do a slope of 9/7 if I can't go up and to the right? Which would mean?
Down 9 into the left.
Right. It's kind of like making it a double negative, okay? Down 9 and back 7. And if you're like me, you'll make it solid and forget, and then you'll write a little note that said this was supposed to be dotted. You can do that, I don't care. All right, and it is below that line that we are trying to include. All the points below that line will work. I know some of your teachers would have said test a point like 0, 0 and make sure it works, right? 0 is less than 5 is true, so it works down here where 0, 0 is. All right, the other line has an or equal to, so it's going to be a solid line, and it has a greater than, so we're going to shade above. That didn't work. Trying to scroll down. There we go. So down at -8, I can't go down 4 and over 7, so how can I do that slope? I can go up 4 and left 7. And this time it's a solid line. And I'm shading which way? So where is the area that worked for both of those equations? Okay. The area bounded in here, yes? Okay. So we had below the green line and above the red line. Including the red line, yep. Everybody okay? Yes. You can. You can just shade that area bounded by both lines. I usually draw lines and then just shade the final answer, but you can do whichever you want. Yep. Just has to be clear where the final answer is. All right, what's different about 4? We got to rearrange it or use intercepts or something. Now the first one, when you go to get the y by itself here, you do have to divide by a -4. And what is the special little alarm that should go off in your head when you divide by a negative with an inequality? Good. So we will have y is what?
Y is
less than 3/4 x plus 7. All right, so it's going to be a dotted line, and we're going to shade where? Below it, right? Because we ended up with a less than after we flipped the inequality. All right. Yeah, that's not, I don't think I did that one right. We're supposed to be going down 3 and over 4, right? Is that right? All right, and shading this way. So all the points over here work. And the other one, if I do this one in red, I'll have 8y is less than negative 9x minus 64. This time, do I flip it? No, I get y is less than negative 9/8 x minus 8. Anybody else get that? All right, so it starts down at negative 8, but I can't go down 9, so I have to go up 9 and back 8, which is dotted or solid? Dotted again, above or below? Below. Now, where's below? Yeah, kind of to the left over here, right? So where's the area we're going to double shade or triple shade or shade at all? Or yeah, it's bounded, has very little positiveness, right?
Like me.
There's a little bitty bit there that it goes above. Otherwise, it's all down in this third quadrant. So if I tested 0, 0, it should work where? Actually, it's below the green line, right? So if I put it in here, I get 0 is greater than negative 28. That's true. But if I put it in the bottom one, I get 0 is less than negative 64. That's not true because 0, 0 is not below the red line. All right, we okay? All right. Substitution, we have talked a little bit about in this class when we did some things, but we're going to solve by putting one equation into the other, replacing one variable with an expression. So this says replace y with x minus 1. You could do this differently. You could mess around with that first equation. But I'm just going to take the y out of the first equation and replace it with an x minus 1. Does everybody remember this method? Okay, so solve this and see what you get. Ten seems right to me. Everybody okay with x is 10? Are we done? Because we're really trying to find what? Yeah, a solution for a system which is an ordered pair as long as they're equalities, not inequalities, okay? So we need to find the ordered pair. When we're done, we're going to have 10 something, okay? Yeah. We can just plug it right back into either one of them, but this one's set up nicely, right? It'll say y equals 10 minus 1, which is 9. Now that should work in both equations. If I put 10, 9 back in this one, I get negative 20 plus 36 equals 16, which is true.
I like how she tells us because she knows we didn't just do that.
Anybody lost? All good? All right, what are we going to do on this one? We could do some rearranging, but is there an easier way?
Plug it into that.
Just take all of this stuff that's equal to y and put it in for that y, right? So it'll say negative 3x minus 6 equals 9x plus 6. Now this is a really good one to make arithmetic mistakes on. Yeah, whatever order you want to do it in, but just be careful because it's easy to get 0 or something. Or 2. Anybody get negative 1?
Yes.
How many of us did not get negative 1 the first time?
I almost did it, but then I saw it before I
Are we done? We got to plug this back in. One or the other of these equations up here. It doesn't matter which one. Negative 9 plus 6 sounds like negative 3 to me. So we get negative 1, negative 3. Anybody remember what kind of system that is? When it has one solution?
Consistent.
Yes, this is a consistent system. It's also called consistent and independent, but these are two intersecting lines. All right, what craziness is going on here? They want us to still use substitution, so we're going to have to rearrange one of these. Can we pick the bottom one maybe? What could we do down there? Negative 8 minus 2x. And then plug it into the top one for the y. Something freaky is going to happen. Freaky is the way I made that 8. So we get negative 4x plus 16 plus 4x equals 7, which is 16 equals 7, or if we subtract 0 equals something not equals. It doesn't work, right? We write no solution, and what does that mean? They are parallel lines. Good job. And this is called an inconsistent system. It has no solution.
I just remember the L's are parallel. So there's two L's, but there's only one R.
Okay? You could write any of those three things on your paper, your quiz on Thursday, and I would take it. No solution, or parallel lines, or inconsistent system.
Can you
Okay?
give me extra credit if I write all three?
No, but it was a good thought.
I thought I'd try.
Yep, Friday is school improvement. I have to be here 9 hours, and you don't have to be here at all. Okay.
That really sucks. I'm sorry. I wish I could.
I'm always here 9 or 10 hours, so.
I don't want to be an adult.
Solve each system by elimination. Guys, super quick review of elimination. Remember when you would have something like this? And you would go, oh, if I just add those together, the y's would drop out. Remember that? That's elimination method, okay? This is my favorite. I like elimination. All right. Then sometimes it got a little trickier, and we had to, this is what I always taught in my class. I would say to them, we're going to wish on the algebra fairy that there was something right here to make this drop out. What do we wish was right there in front of that? A negative 2, okay? Well, we're in Precalc, so we're going to have to do a little extra wishing, because this is not just going to drop out by itself, but we can do only one multiplication on this. What could we do?
Multiply that by the top by negative.
Okay, the top by a negative 3, so that we would get a negative 12, right? Everybody okay? So we have to multiply all the way through both sides. So really, I suppose if I were being a proper math teacher, I'd write the negative 3 on both sides. All right, we get negative 12x plus 21y equals negative 78, I think. And then we have 12x plus 4y equals 28. I just rewrote that one. And we have 25y equals negative 50, so we get what? Y is negative 2. We still have to plug it back in somewhere to find x. Doesn't matter which equation over here. 12x plus 4 times negative 2 equals 28. So this is 12x minus 8. Add 8. Trying to show all my steps for you. X equals 3. Now, I'm going to say this and try to say this over and over this week. If you get to the end of this question and you plug that ordered pair back in and it does not work in both equations and you cannot find your mistake, no. There is a mistake. If you got an ordered pair and it doesn't work in both, bring your quiz up to me and say, I know this answer is not right, but I can't figure out what I'm doing wrong. Because I don't know about you guys. I can do 3 times 2 is 5 over and over and over and not see my mistake. Do you know what I'm saying? Or like up here, I could multiply the left side by -3 and not the right side by -3 and do it over and over and not find my mistake. If you know it's wrong, I'll help you find your mistake. I'm not going to fix it, but I'll show you what you did wrong. All right. What's going on here? What could we do? Actually, there's 2 things we could do. We could actually divide this bottom one. Do you notice they all have a common factor? Most of us probably wouldn't do that. We'd probably take the top one and do what? Multiply it by what? To get rid of, maybe by a -4 on both sides? Be careful. What's going to happen? When I add these, what does that mean? I get 0x plus 0y equals 0. How often is that true? So this is many solutions. These are actually what? The same line. This is actually called a consistent and dependent solution. Because they're consistent meaning there is one solution, and dependent because it's the same line. You don't have to know that vocabulary for this quiz. Now, let me ask you this. Does the ordered pair 1, 1 work? You said there's many solutions or infinite solutions. Yeah. Okay, if I plug 1, 1 in, I get -7 equals -5. How can there be infinite solutions but 1, 1 doesn't work? It's not on the line. There are infinite solutions, but they have to work in the equation still, right? They have to be on the line. So in other words, I've graphed a line that has infinite points. Then I went back and I was going to graph the other line, and whoops, it fell right on top of that one. So they have infinite points in common. But does this point up here work? No, still doesn't work, okay? So there's still points that don't work. All right, we're going to solve one more by elimination. This time we need a lot of wishing. These don't go into each other at all, so what do we have to do? Like maybe the top one by 2 and the bottom one by 3. Will that work? 6x minus 14y equals -8. Notice I got slacking and didn't write it on both sides this time. -6x minus 12y equals 60. Did someone else get that? -26y equals 52, which is -2. And that's where you'd make your first mistake, right? Sign mistakes are really common on these too. Really easy to make a sign mistake. And that messes up the whole rest of the problem. So I got -2. Now I got to plug that back in somewhere. I think I'll go with the top one this time. 3x minus 7 times -2. Yep, that's a good one. Yep, put the x in for the y and solve again. That's another mistake we all make. I got -6, -2. Anyone else? 10, yes. I got 10/3 the first time I did this problem as well. Anyone get a 0 anywhere? That's always usually. Oh, are we good? All right, now we get to one that's a little more pre-calcy. It's really not that bad, guys. The very first day in this class, we solved equations that had fractions all over the place by doing what? Multiplying through by not the reciprocal. Because 1/2 and 5/2 don't have the same reciprocal. Multiply through by the least common denominator. Now, somebody's going to look at this one and realize that you could multiply by something else and then you'd be done and ready to add to this, but I'm just going to go with 2, okay? If I multiply through by 2, I get 2y plus 1x equals 5. Nobody's lost yet? Okay. Now the bottom one, I'm actually going to just move the 13 to the other side so that it says 7y plus 5x equals 13. How many of you is going to bother you because I have the y's in front of the x's?
I actually like this. Yeah, no, I don't know. We'll see how it goes.
What do you think, Sarah? What should we do now? No? Multiply what? The top by 5? You could do 5 and then you'd have to subtract, right? Or you could do a negative 5. Because I wish this was a negative 5 so that when I add it here, the x's would cancel. If it's bothering you, rewrite them in the right order. It's okay. Okay, I'm multiplying through and writing it down here. So I get negative 10y minus 5x equals negative 25. Then I'm going to add these two. Because they're not in the right order? Is that what's bothering you? Positive 4? Somebody else get positive 4?
Yeah.
Okay. I think I'll put it in this equation. It is a y, so I get 13 equals 7 times 4 plus 5x. Okay, I'll humor you. I'll plug it back in. 4 plus 1/2 times negative 3 equals 5/2. That would be 8/2 is the same as 4 plus negative 3/2 is 5/2. Does that seem okay? The second one would say 13 equals 7 times 4, which is 28. Plus 5 times negative 3, which is negative 15, is 28 minus 15, 13. 28 minus 15 equals 13. Okay. So it does, check. What? Gotcha. By 2 and 7, negative 7 or something. All right, guys. Solving by elimination with 3, you're going to hate. I'm just telling you right now, okay? But I'm going to make you do this without matrices on a quiz on Thursday. Here we go. Here are the steps written out for you. First of all, you choose a variable to eliminate. Yes, I'm going to eliminate. 2, you're going to eliminate that variable using 2 equations. With either adding or subtracting. Okay, 3. Then you're going to use 2 different equations to eliminate the same variable. If I could spell that, it would be really good. I can't type today. All right, and then you're going to solve that new system you have with only 2 equations, okay? With 2 variables. All right, so that's the general idea. Sometimes it helps students if I write it out. So we are going to pick a variable to eliminate here. Now, we're going to have to do some elimination, like we've talked about, adding and subtracting of equations. So does y look like a good choice? 3, 6, and 4, does that look really fun? Not so much. X wouldn't be too bad. Z's look really nice. Okay, so let's choose Z here. Then we're going to choose 2 of the equations to add together and eliminate the Z. Which one do you want to do first? The bottom 2? Okay, so we're going to add these bottom 2 equations together. What do we get? Okay, we're down to an equation that has 2 variables. Do we know how to solve a system if it has 2 variables? Yes, but we need another equation to go with it. So we go back up here and we pick a different 2. Now, we're going to have to reuse one of them, but we got to use this one up here too. So can we pick the top 2? Okay, if I add the top 2, what will I get? Oh, look what happens. The x's and the z's drop out, right? So I get 3y equals negative 12. Now, normally at this point you'd have a system with 2 variables and you'd have to solve it. But we're really lucky because one of them's already pretty much solved, right? What do we get? We get y equals negative 4. Where can I put that back in and it will help me? The red equation is correct. I want to put it in here. If I put it back in one of these up here, I'll still have 2 unknowns. If I put it back in this red one, I'll have negative 4x plus 2 times negative 4 equals negative 4. Did anybody get negative 1? Okay. Now where do I put those 2? Sure. In one of the very first, one of these equations that had 3 variables, if I pick the very first one, I get negative 1 minus 3 times y, which is negative 4, minus z equals 7. This becomes 12. Negative 1 plus 12 would be 11 minus z equals 7. How about 4? Z 11. 11 minus 4 is 7 on a good day? Okay, so we ended up with an ordered triple of negative 1, negative 4, and positive 4. We could check it in any of these equations and it should work. Actually, it should work in all 3 of these equations, okay? 1 minus 24 is negative 23, plus 4 is negative 19, and so on. Okay? All right, ready to try again? I believe some of them do 3-dimensional graphing now. I just don't know how to do it. All right, guys, which variable do we want to eliminate on 13? We only got 5 minutes. We got to go quick. I think I'm going to, y might be good. I'm going to try x because I can add the top 2, okay? So my first choice is I'm going to choose x. The second thing I'm going to do is add the top and the bottom. How's that one? Add numbers 1 and 3. I will get 7y plus 11z equals 35. Okay. Now then it gets a little more complicated. How about if I use equations 1 and 2? And I'm going to eliminate the x, so I need to multiply 1 by what? I have to get rid of the same variable again. So if I take the top one through by a 6, and I rewrite it over here, I'll have 6x plus 18y plus 36z equals 126. Now I'm just rewriting this one underneath it. And then I'm going to add those two. Okay, this is disgusting. Because these are the two equations we now have to work with. The numbers aren't pretty, right? All right. I'm just going to go ahead and do some miserable math, okay? I'm going to multiply this one by a 22 and rewrite it.
22 times 35? Yeah.
It's okay. Something magical will happen. 154y plus... Yes, 242z equals 770. What do I have to multiply this guy by? 7. A negative 7, maybe? Okay, I get negative 154y minus 238z equals negative 770. So I end up with 4z equals 0 when I add those. So I get what? Okay, now where could I plug that back in? Anyone that has two variables. Okay? So if I plug it in here, it'll say 7y plus 0 equals 35. So y equals 5. Now what?
Those both back in.
Go back in like the very first one.
Sure.
So it will say x plus 3 times 5 plus 0 equals 21. 21 minus 15 is 6. So I got 6 and then 5 and then 0. If I check it in this one, I'd have negative 36 plus 20 is negative 16. That works. Negative 6 plus 20 is negative 14, or is 14 plus 0 is 14, so it works, okay? More fun tomorrow. But you can now get started and do worksheet 3 and 4, okay? You can do most of worksheet 3 and 4. 5 is word problems. You can certainly do them if you're good, but we haven't done any notes on those yet, okay?